Search Committee, and welcome to my first teaching demo. In this demo, we're going to be talking about data visualization in R. Our learning objective for students in this exercise is first that they'll understand the basic components of plotting with ggplot2, that they will practice using ggplot2 to construct a plot and use that plot to understand the distribution of real-world company data. And also students will learn how to generalize these specific skills from this tutorial to other data contexts. And this is part of why one of the first and primary learning goals is that students really fundamentally understand how ggplot works and how they, as coders, are communicating with it so that they can generalize that graphical coding language into other data analysis contexts. So first, I just want to say that in this workshop, I'm assuming a base level of comfort on the part of students with R and RStudio. In a previous exercise, I would have guided students through downloading R and RStudio, creating tables, working with vectors, manipulating the shape of data, and also installing packages and the concept of R as a language and packages as the customizable scripts you can use for flexible computing. So all of that, just kind of a basic entry level of working with R will be necessary for students to be able to continue on with this workshop. If you look exclusively at the descriptive statistics of your data, you can get a lot of information out of that, right? We know in this data set, say we have X and Y, and they're both continuous. And our standard summary output would give us something like this. The mean of X, the mean of Y, their standard deviation, and their correlation. So we're getting an idea of the average central tendency, the spread, and their relationship to one another. So here is an example of a set of data that would have this descriptive output. So if I'm only looking at this descriptive output, I'm learning a lot of things, but I'm actually not learning what the data distribution looks like, if there's any irregularities in it, if I might have multiple groups going on through a bimodal distribution, etc. All of that would be obfuscated within the raw descriptive statistics. For example, here is another data set that has the exact same descriptive statistics as the one on the left. This clearly is an unusual data set and would probably raise some eyebrows if you actually looked at it, but you would completely miss this pattern if you had only looked at the raw statistics. And the same is true for all of these different data sets. Every single one of these different data distributions has the same descriptive statistics as the first one that I showed. And so for this reason, data graphics is a very important part of coming to understand your data in the first place. So in order to do that, we're going to rely on a package called ggplot. If you don't remember how to use packages, here's a little reminder. You have to install each package the first time you use it. You have to load it from your library every time you use it. And today the package that we're going to download and load up is called tidyverse, and tidyverse contains a very helpful package called ggplot2. Now, part of the reason that we use ggplot instead of some of the more simpler graphing functions is that ggplot is very powerful and very flexible. So this is an example of a graphic from the New York Times that was developed using ggplot. And this is showing the impact of mass incarceration on Black families in different cities in the United States. And so by having a physical graphical representation of this data, we can develop a better understanding of how mass incarceration is impacting people based on their human geography. So this is not something we would be able to do based on pure data analytics alone. So in ggplot, ggplot builds every graph from 3 core components that you have to have. The first is a data set, so you need to give it information that it's plotting in the first place. The second is geomes. So these are visual marks that represent data points. So it's the translation of the data in your data frame to some sort of meaningful system, whether that's location or color or size or whatever. It's mapping the data that you've pulled out of the data set that you specified onto a specific dimension. And the last is a coordinate system. What data are we picking and where should it be going? And ggplot has some pretty advanced methodology. So this is just an example of how ggplot would work in a simple correlation plot. But also ggplot can use geomes to track data onto colors, like we saw in the mass incarceration maps that I showed before, right? That data is being represented visually through color instead of through location on the plot. So here is an example of me setting up a ggplot with these three basic components. So the first step that I take is I specify the data that I am going to use. In this case, in our workshop, our data will be called salary.data. Second, I specify what data are we looking at out of this data frame and where is it going. So I specify that our x variable is going to be the name of the department, and the y variable is going to be the salary rate. So I'm specifying in this data frame that has 5 different variables, you should pick out those 2 variables, department and salary, and put the department on the x-axis and the salary on the y-axis of this plot. And then finally, once I have saved G, so that's my graphic object that has the information about where's the data and what are we picking, I save that and then I add onto that a layer. Now this is the graphical layer where the genome will translate the values in our data frame into a meaningful representation, whether that's through location or color or what have you. Now for the next part of the tutorial, we're going to turn over to R so we can practice doing and implementing this code ourselves. So first we need to get some data to work with. Now the city of Greensboro actually hosts a lot of employee data free online, and so we can read this CSV from their website directly into R. So if we want to get, again, kind of a more descriptive statistic based understanding of what our data looks like, we can use the summary function, and this will show us for each of our variables, it'll summarize it for us. So for the categorical variables, it's giving us counts. Here we see there are 45 people with the last name Johnson that work for the city of Greensboro. You can see down our last variable is our only quantitative variable, and that's salary rate. And so here we have the minimum, the medians, the means, the quartiles, kind of descriptive data. Let's say we want to get a better understanding of how the salaries in the city of Greensboro are distributed amongst the various departments. So here I am creating a graphics object using ggplot and saving it to this object G. And so the necessary information I need to do that, as I showed before in the PowerPoint, is I need to pick my data. Here I'm telling it to use the salary.data data frame, and then I also need to specify the coordinates. So here I'm saying the variables we're interested in here are department name for the x-axis and salary rate for the y-axis. So if I run that, I end up with an object, and then what I do is actually shows up down here. So this is my graphing object. It doesn't exactly look very pretty yet, right? We can't tell the different department names because, like, look at that. But that's okay. ggplot is very flexible, and we can fix that later in order to make it more interpretable for human eyes. So next what we're going to do is we're going to map a layer of data onto this plot by entering the command geom_boxplot and adding that on top. And so what we get is this nice little box plot. Each of these box plots represents a different department and the salary range within it. So again, it's still not very sexy looking, but we have the basics of a box plot, and from here we can build on and add attributes to make it easier to understand, interpret, and use for our own purposes. So the first thing I notice is that two things. I can't read the labels on the x-axis, and we have a big outlier over here that's kind of distorting our ability to see more in depth what's going on with the other departments. And so you see that each of the different components that I'm going to add in this command, you're literally adding it. It says plus, right? You're layering it on top. So you keep your original command here, and then you add elements to customize. So I do that. Hey. All right. See, now we can read each of the different department names on the left, and we can get a better understanding of their distribution and the size of their department on the right. And in the next phase of this exercise, we actually will go in and talk about how to interpret a box plot, what each of the different lines mean, and how we can use that to understand employee data better in organizational contexts. Hello, committee, and welcome to demo number 2. This time, our lesson will be on sampling and database decision making. Now, in this exercise, our goal is to help students understand the necessity of representative sampling, particularly around the concepts of sampling on the dependent variable and why it's important to avoid doing that, and also confirmation bias and how human psychological processes can lend us to certain kinds of decision-making biases based on what kind of data we're using to make those decisions. And finally, this exercise is actually done in an interactive kind of case study framework. And the purpose of that is to give students hands-on experience with database decision-making in a high-stakes context, where those human factors will purposefully come into play as they are making their decisions. So this entire exercise is based around the Carter racing case. And now what students are asked to do in this case is they are put into the shoes of John Carter, who with his brother runs a race car company. And Carter Racing, they're on their last race of the season, and throughout the season they've been having issues with blown gaskets in their cars. And blown gaskets is a huge issue because it costs them time, money, sponsorships, and so they're facing a lot of pressure to have a successful race with no blown gasket. And so they have two potential options. They can run the race and risk blowing a gasket on their car, which will lead to massive financial losses, or they can not run the race, and while they won't have as many financial losses, like not to the same extent as if they run and blow a gasket, if they don't run, they will lose potential advertising and partnership deals. So this is a forced choice, race or not race. And as they're making this decision, they have some information from the mechanics of Carter Racing. Now there are two central mechanics giving opinions in this case. The first one is Paul, and he's an engine mechanic, and he thinks that the engine problem is related to ambient air temperature. On the other hand, there's Tom, who is the chief mechanic, and he disagrees, pointing out that gasket failure has occurred at all temperatures, and then based on that concludes that temperature cannot be the issue that is causing gasket failure. And so their decision is based on the data that Tom and Paul have given them. So generally, here's how this exercise goes. First, students read the case and they make an individual decision, race or don't race, and I have them write it down to keep themselves honest. Second, students are assigned to groups of about 3 to 4, and those groups each come up with their own name. And those groups have 25 minutes to discuss the case and the data they have, and to reach a group decision. And once the group has reached a decision, they write their decision on the board next to their name. Now during this 25-minute group discussion period, my job as a teacher and facilitator is to float around and be the mechanic. So if anyone has questions during this period, if they would like more information or they need clarification, they're allowed to ask the mechanic, me, at any time. So going back to the case, as I said before, there are two competing mechanics with different theories on why gaskets are blowing in their cars. And the chief mechanic presents the following data. So this is the data given in the case study. This is the ambient air temperature at which all of the gaskets blew in races where they did have blown gaskets. And now, while this is useful information, what is critically missing from this information is information on what happened when their car did not blow gaskets. So in essence, what the mechanic has done here, he's sampled on the dependent variable of races where they did blow a gasket. And so the student's job is to recognize that that data is missing and ask for it. And for the most of the teams often do not do this, which is the point of the exercise. But usually a few of them do. And so if they ask the mechanic for additional data for ambient temperature when races do not have blown gaskets, then you as the mechanic can give them the missing third sheet from the case study, which has the missing data. So this is the data for ambient air temperature on races where they did not have a blown gasket. So together you have a full sample, and only with the full sample can students come to the correct conclusion that they should not be racing, because if you look at races with and without gasket failures, so with failure is on the top line and without failure is on the bottom line, there's a clear association with ambient air temperature here. And in the particular case study, it is supposed to be cold on the race that morning, making the answer very clear. It's like 40 degrees that day. It's not even on the chart anymore, that they should not be racing. But they can only come to this conclusion if they have the full set of data. So once teams has made their final decision, I asked teams to stand on one side of the room or other based on whether they decided to race or not. And then I lead them through a moderated discussion where I ask them why. Who decided to race and why? What factors went into their decision? How did they as a group reach their decision? What was their actual procedure? Those kinds of things. And in the course of this discussion, what typically comes out is the fact that a few of the groups will have asked for data and will have gotten the right answer and reveal kind of implicitly to the class that there was more to obtain. You reveal to students that yes, the correct answer was you should not race. And part of the reason we know it's the correct answer is because the data from this exercise are actually taken from a real case study. So this data is designed to look, to be modeled off of the Challenger shuttle decision. And so the Challenger shuttle, if you're not familiar, blew up 74 seconds after liftoff. Leading up to the decision to launch the rocket is they had repeated O-ring failure at low temperatures, but they were only looking at instances where O-rings had failed and not instances where they had not failed. And so because of that faulty sampling, they made the incorrect decision to launch the rocket that killed all of the astronauts and the teacher that were on board. So this introduces students to the concept of sampling on the dependent variable. It's the idea that it's very important to have a full representative sample in your data if you're going to be making decisions based off it, because if you sample on the dependent variable, you don't know what happened in all of the other cases where it was not, where the outcome you were focusing on did not happen. So for example, in the domain of leadership, we often see these Forbes 100 lists, right? Top leaders, like what a prime example of sampling on the dependent variable if we're going to look at these people and say, what is leadership, what makes a good leader based purely on who the top leaders are. If we ask that question, what we're forgetting is that all over the world there are tons of people who are not on this list that may have the same characteristics that we're picking up, but we didn't observe them because we only considered the instances of leaders and not leaders. Another important detail that is brought up in this case is the concept of confirmation bias. So in the Carter racing case and in the Challenger shuttle decision, the social context in which people were making data-based decisions was very high stakes. There was a lot of time, monetary, and social pressure to go in favor of launching or racing. And because of that, it seems like the people who were making decisions were motivated to search for information that confirmed their pre-existing decision to launch a race. And what that phenomenon is confirmation bias. And so this case study presents a really excellent example where students almost always fall into this trap because of the contextual basis in which the data is being considered. And so it's another way to really bring out the influence of human social processes on these database decisions that people often assume are free of social context or unbiased in some way because they involve data. Hi, I'm Amelia Stillwell, and this is my third teaching demo. And in this exercise today, I'm going to be talking about science deep dives as a tool for guiding students through the interpretation of data and also through ethical considerations when it comes to big data in corporate contexts. So our learning objectives for students in this exercise is first that they will learn to understand and interpret data through reading primary research articles. And this is a difficult skill that takes multiple iterations of the science deep dive, in my experience, for students to pick up. But I really like this activity because it's great at breaking down the different information that appears in scientific articles so students know where to find it and also how to interpret it and how to evaluate it for themselves. We also discuss with students the difference between data and the interpretation of data. Particularly in the article that I select for this exercise, there are some causational claims that the authors make when they have very advanced but still correlational methods. And so I think that brings up a really interesting conversation about data and its interpretation, and also a discussion about the difference and importance of distinguishing between correlation and causation when it comes to data analysis. And finally, at the end of the exercise, we reflect a little bit on corporate responsibility around big data collection and also monetization in today's world. So in general, because this article relies on primary research articles, students do have to do advanced preparation. And so for this exercise, I have students read an article and fill out a structured summary for homework, which is due before class. And then once they get to class, students form small groups where they review the questions from homework, engage in small group discussions, and then we report back to the class and have a larger moderated discussion as a whole. So to give you a little bit more information about how I have students prepare for this exercise, I have them write up a one-page summary of the research article. It doesn't have to be like a actual essay or anything, but there are 12 key questions that students are expected to answer using the research article. What problem does this article address, or what is the research question? So this asks students to focus on what is the point of what we're reading here today? Why is this problem or question important? What is the researcher's proposed hypothesis? So what is the central claim they're trying to make with this data? Who are the participants in the study and how did they get the sample? What are the independent variables in this study and how are they measured or quantified? So this again brings up the distinction between the variable itself at a conceptual level and then the variable at the level at which it is operationalized or measured. Same for the dependent variable. What is the dependent variable in this study and how is it measured? Distinguishing between the conception of it and its actual measurement. What results did the authors find in this study? Do the findings support the author's original hypothesis? Why or why not? This is one of my favorite questions because this question really asks students to evaluate the evidence in the article for themselves, which is the goal for this exercise and also my classes in general, to give students the ability to evaluate evidence on their own. What conclusions can be drawn from this study? What is one particularly good thing about this paper? And also, what is one flaw that you see in this paper? And last, I have students pose a discussion question for the class, such as by integrating what they've read here with other content from the course in previous weeks, or applying the subject of the article to an applied setting, something that would generate student discussion. And these are the questions that I pull from when I am generating class-level discussions for students' small groups, so that it's really reflective of the subjects that students are interested in and have expressed a desire to talk about in their homework assignment. Now, in this particular deep dive, the paper that I'm going to use is called Deep Neural Networks Are More Accurate Than Humans at Detecting Sexual Orientation from Facial Images. And what the researchers did in this study, in essence, is they took facial photographs from people, publicly available photographs of people from a dating website and also from Facebook. There's two different studies, they replicated it. And they basically used advanced data analytics to make a predictive algorithm that could classify people based on their gender and their facial landmarks, so using facial recognition software, facial landmarks, as to whether they were heterosexual or homosexual according to how they had self-classified in their dating profile or Facebook profile. So what this was is a very advanced classification algorithm. And basically what the authors find is using only facial cues, they are able to classify people as heterosexual or homosexual better than chance. And so in essence, what they're arguing is that the computer is able to detect people's sexuality based on their face alone. Now, this article was published in JPSP, the top journal in social psychology, and generated a ton of controversy when it came out. And it has a lot of ethical issues associated with it that make for a very great discussion. So some of the things that sometimes come up are distinguishing between the variable and the way it's measured. Is self-identification a good way to measure sexuality, for example? Is bifurcating people into two camps a good way of measuring sexuality? Is it ethical to perform research on people's faces when they haven't given consent for the photos, even if the photos are in a publicly available domain? What level of privacy do people come to expect when they're on a dating profile website versus other types of websites? Those kinds of questions. So, in class, first, students review their homework questions and the student-generated discussion questions that I've taken from their homeworks and given back to them in their small groups, in groups of about 3 to 4. And this is their opportunity to really go over the homework as a group and engage in peer-to-peer learning and tutoring and teaching. At the end of about 30 minutes, we come back together as a class, and I ask the groups to report back what they talked about in their discussion. We both go through the entire article itself, answering each of these detailed questions, and importantly identifying not just what the answer was, what was the hypothesis in this article, but also where in the article they found it, so that students later will know how, for other research articles, to go in and find the information that they're looking for. And then we also, in the context of this broad group moderated discussion, take on some more of these broader ethical issues. I like to bring up broader ethical issues related to big data, data analytics, and the mass collection of data by corporate and public organizations. Because there are very important questions that people have started asking that are becoming increasingly important as big data becomes used by more and more industries. Questions such as, is data a form of property? What data rights would you want to have in an ideal world? And how do you balance, as an individual or as an organization, how do you balance the risk of providing data access with the utility of sharing? So these are important questions for both individuals and businesses and organizations to consider as big data becomes ever more influential across industries in the United States. Thanks, that's all I have for today, and have a great weekend.